Good morning, everybody, and welcome to Gator Bio's webinar titled Strategies for Accurate, Easy, and Fast Quantitation of AAV Serotypes. My name is Subodh Nimkar, and I'm the Marketing Director at Gator Bio based in Palo Alto, California. Today's webinar is split into two parts. I will do a brief introduction to the company and products, and then the main part where Indrani will present Gator Bio's AAV serotyping solution. Before I get into the details, I would like to do some housekeeping items. Everybody, all the attendees are muted, and please enter your questions using the Q&A box in your Zoom window. We would like to present to you a quick 3-question survey after the webinar. This webinar is being recorded and will be made available to all registered attendees within 24 hours of the webinar. With the housekeeping items out of the way, I would like to briefly introduce you Gator Bio as a company and our relationship with the Biolayer Interferometry. Gator Bio's has a long legacy around BLI. Hong Tan invented Biolayer Interferometry and founded Forte Bio in 2001. A prototype BLI instrument was developed in 2002. This was then commercialized as Octet in 2006. After that, Hong Tan and Bob Zook were still working on BLI because they knew the limitations of the first-gen BLI and were itching to come up with something really more exciting. And that's when the next-gen BLI idea came into picture, and they formed Gator Bio in 2018. And in a very quick time of about 2 years plus, the 2 BLI systems were launched, Gator Prime and Gator Plus, and those systems are available in the market today. A little bit more about the company, because some of you may not be very familiar with Gator Bio. We are a company on a very solid footing, both in terms of our funding, which is over 100 million, a solid IP position with more than 50 patents granted. Interestingly, the technology was first commercialized for diagnostic purposes on a Pylon platform. And this was commercialized for diagnostics in China first through a sister company called ET Healthcare. And there are more than 2,000 systems installed in China. In the United States, where the same technology or similar technology was now ported onto a research instrument, which is a Gator, and we have in the last 2 years sold significant amount of instruments, I would say in the high double digits, and growing extremely rapidly. The biosensors, the heart of the BLI instrument, they are manufactured in Palo Alto, California. Our key R&D is based in Palo Alto, California. As far as supporting customers like you, we have experienced field scientists and engineers all over the country who are helping our customers be successful with our platforms. We support 3 main applications, as most of the Biolayer Interferometry technology does: quantitation, kinetics, and epitope binning. The BLI platforms really fit well in the entire pipeline of biotherapeutics discovery, starting with early discovery, where we do antibody titer measurements, going to early development, doing epitope binning. When it comes to lead antibodies, then binding kinetics. Further downstream in process, scale up, doing quantitation, and then at the end, at the CMC, manufacturing and QC, kinetics measurements. So really, the Gator platforms fit into every stage of biotherapeutic development. As I alluded to before, Gator Bio offers two platforms, Gator Prime and Gator Plus. They are differentiated primarily based on their throughput. There is a wide range of biosensors and consumables that are being offered, and also the application-specific software. The software provided with the Gator platforms incorporate data acquisition, analysis, and reporting of 1 or 2 plate operation on both our platforms. As I mentioned before, we have a significant IP and strong position in developing biosensors. Today, as you can see on this slide, we have a range of biosensors supporting different applications. We also offer on-demand probes, and some of those are listed here on the right-hand bottom corner. And then we have a service for custom probes. Today's webinar is around our new biosensor probes, primarily designed for AAV serotypes. And Indrani will be going into more details about the data and how we have developed this and what's the value proposition that we bring to the table for all the customers like you who are involved in gene therapy, viral vectors, as well as cell therapy. With that, I would like to bring in Indrani to give the main talk. Thank you.
Thank you, Subodh. And as my title suggests today, I'll be talking about strategies for accurate, easy, fast quantitation of AAV serotypes. We are very excited about our AAVX biosensor that we launched recently on September 15th. And we are overwhelmed with all the responses that our sales and marketing team has been getting. So we thought of introducing and having a webinar so that we get you guys familiarized with our biosensors. And not only biosensors, but also our technology. Because we realize that we have been mostly serving the antibody, small molecule drug discovery or the peptide drug discovery markets in our recent years, but we haven't explored quite the AAV or the gene therapy field. Now, we are very much aware that some of you might be very well aware of the BLI platform, as well as the label-free analytical assays. And some of you might not be aware of it. So Biolayer Interferometry or BLI is part of the label-free systems that has many other biophysical techniques where label-free meaning you do not have any dye or fluorophore or any kind of special tags that you need to conjugate to your molecule of interest in order to see binding by using a fluorescence or chemiluminescence or anything. All you do in this technique is we are using white light, and that's all. And this is a very robust bioanalytical techniques, and it has been in the lab for almost 15 to 17 years, where the researchers are utilizing this, as Subodh mentioned, in several applications. But we can say that this probably is the first direct application of a label-free biosensor for the gene therapy, especially for AAV. Now, if you look at the basic principle as how this BLI works, this is our biosensor that Subodh was mentioning. So our machine has 3 components: the machine, the biosensor, and the software. So this is the biosensor where all the reactions takes place, especially on these 2 ends of the tip. Now, if you visualize these 2 ends and have the biosensor imagined in this cartoon, What happens is we have the white light that is passing through here, and this biosensor has two layers. One is the optical layer, and this is the surface layer. Now the optical layer is constant, and surface layer is where we do the modification. And here we can make customized, or we customize the surface layers in order to make special probes. So in this AAVX probe, what we have done is we have an antibody that will bind to the AAV serotypes is what it is attached. Now, if we look at the, how animation, that how it works, is when the light is incidented, it will be reflected back from these two surfaces. And that's what you can see the intensity of any changes in the wavelength. Now, if anything binds, what happens is that in reflective index, it beam changes, and you see a nanometer shift over time. So this is a real-time binding phenomenon that is occurring, and you can record that in front with your software. So, and then when you have your ligand bound, then you can dip it in another solution where you will have analyte of your interest, then it binds on top of it. So this is where you are kind of doing a kinetic experiments where you are calculating the on rate. And then again, you have the probes. If you move it into the buffer, what happens is this analytes that bound, they slowly dissociate. Then you see the dissociation in real time, which gives you the off rate. Now you have the on rate and you have the off rate, so you can determine the KD or the binding constant. So most of it is being used for quantitation, where you see the direct binding to the surface of the biosensor. Or what you see also is the kinetic experiment, where you see the follow-up experiment of the on rate and the off rate binding. Now, giving that background on the BLI, now let's see how our instrument works. Now, if so, this instrument, this is a picture of the instrument inside, and we have currently two models, Gator Prime and Gator Plus, and both of them hold two plates. So one plate is meant to be where your biosensor you will keep, which it needs to be hydrated in the buffer. And then when you just hit the button start, there is this picker which picks all the sensors, and then it moves to your reaction plate. And in reaction plate, you have the software where you have set up your experiments, and you ask it to go to different wells, and thereby it just moves from one well to another well. Now, having this system also gives you a lot of advantage, because if you can see just the interior through this video, you can see that there is no fluidics involved. We do not have any channel, we do not have any flow cells where the buffer is going or in and out. And because there is no fluidics, so you can imagine that the maintenance is very hassle-free, because there is nothing that would be clogged during your experiment that you have to call the service engineers all the time and things like that. So they're very easy to maintain, right? And another thing, of course, easy software. And the other advantage of this technique also you can see is when you have your samples in the plate, they are sitting there, and all you do is you are just moving the biosensor from one row to another one. You do not need to be mixing or adding things to your sample wells. So then if you have very valuable samples, you have that sample left over in your plate for you to do any further characterization that you would be interested in. So you have the sample still left there, even after you determine your quantitation or your kinetics or anything. Now, because it is fluidics free, the other advantage also that you can have cell supernatant, cell lysets, and the plasma also in this, in your assay plate, because there is no chance of any clogging or anything. And on top of that, of course, as Subodh mentioned, that we have so many different types of biosensors, and we can also make biosensor that is specially customized to your need, that you can do anything that you can imagine without having to do any conjugation or any other addition to it. So now, having that into the background, let's just focus on our challenges with AAV. So last year, we have a very extensive biosensor portfolio for our antibody drug discovery, and we were kind of hoping to find out new therapeutics area that we can venture out with our existing biosensor and what we can do in order to have the BLI technology reach to more researchers. And then we thought about the gene therapy, and then AAV definitely was the first one to stand up. And then this research, the review paper that we kind of saw last year, we wanted to see that what are the analytical techniques that the researchers are using in their labs for AAV development, right? And we came across like this paper where it shows that you guys are very extensively using ELISA for your total AAV quantitation. Then you use the ddPCR to do empty and full. Then you have your AUC, which you also do you extensively use to characterize empty and full capsids. At the same time, all the techniques, right, like the TEM and things like that, it kind of stands out because in other drug discovery processes, the analytical techniques are kind of have a lot more throughput. Then we realized that, the challenges that the AAV process and the bioanalytical techniques that are currently being hindered, it is that low throughput and a very long turnaround time for the researchers. And of course, this long turnaround time and the throughput kind of introduces a lot of sample, aggregation and things like that, going from your upstream all the way to your downstream process. Then how do we bring in this BLI technology and improve your throughput and also the ease of doing the experiments, right? So we first, a technique that can be easily converted to BLI is of course the ELISA, and that's where we started. So if we look at the ELISA, then these are the steps that normally is involved in an ELISA technique. So you first prepare your plate, then you add your sample that binds to your plate, that antibody you might have immobilized. Then you do several wash, then you come in with the detection antibody, then you have incubate for some time, then you add your substrate and quench and read. So there's like this long process that is involved. Whereas if you are using BLI, all you do is you have the pre-coated customized biosensor, and you just dip it in your solution of interest, and then it binds, and you see the change in the nanometer shift over time, and you see the binding rate and calculate the concentration. So very simple compared to what we just saw for ELISA before, right? So, but then we did our market research, and we had to be finding out like what are the other equivalent techniques that are currently available in the market for you guys that wherever you are doing AAV quantitation for the full serotype quantitation. And of course, the most versatile analytical techniques that almost every lab is using is the ELISA. And when we looked at the ELISA kits, we saw that the ELISA assay range normally, that the concentration range that where the linear curve fits perfectly is between e⁻⁶ particles per milliliter to around e⁻⁷. So you have to do several dilutions from your working concentration in order to get to your ELISA. So there there is a possibility that you are going to introduce error, right? So this is the concentration range. Then last year, at the end of last year, Zyro Lab also introduced another AAV total capsid quantitation kit. And we saw the concentration range, and that suits more for the current concentration range that AAV, the researchers are interested, which is around e⁸ particles per milliliter to around e⁻11. And then we have our competitor Octet. They also have an application note where they had only published some data with AAV2, and their application note is also in the application note, their concentration range is also fairly narrow. So then we realized that when we are going to come out with a product, we do not only need to not only meet your expectation, but also beat the expectation, in order to stand up. So we need to have that in mind when we designed, and I will show you in my following graphs that where our concentration falls. Now, keeping that and all these things in mind, that what is available for you guys currently in the marketplace to use and do your total capsid quantitation, we wanted to enhance that experience, and that's why we launched this AAVX probes using our Gator platform. Now, if I summarize the basic principle of this AAV quantitation, so basically we are doing quantitation, which is dependent on the rate of this AAV serotype binding to the probes, right, on the biosensor platform. And what we use is, it is a very familiar antibody for all of you guys who are working with the AAV gene therapy, is the capture select anti-AAVX antibody, and we have an agreement with them, and that's the same antibody that basically you guys all use in your AAV purification, which is part of the Thermo Fisher porous affinity column. So the same way that they are attached to those beads, here pretty much similar chemistry we have attached to that particular very robust antibody to the probe surface. So it's very simple. And because the AAVX porous column, it can determine all the serotypes. So the AAV 1 to 8 and 10. So this probe also is robust in working with all your serotypes. So if you have, say, you are working with AAV 2 and 5, you do not need to buy two different ELISA kits. This is one probe solution for all the serotypes that you want to quantitate. Now, as I mentioned, everything is, of course, on the binding rate, and this binding rate is dependent on the concentration, and I will show you later that the binding rate is also dependent on the serotype, because there are very nice review papers that has been published, and not only one, but few of them, which identifies the residues on the anti-AAVX antibody to the AAVX serotypes. So, and if you go through that paper, you will realize that where AAV1 binds to this anti-AAVX capture select antibody is different than where AAV8 binds. So thereby these differences in binding gives different binding rates. And so you will see different intensities in the signal. And another thing that you have to do for using Gator in order to know your unknown concentration is you have to generate a standard curve. I think it's pretty standard, like the ELISA as well, because you there also need to have a standard curve. Now, with that in mind, now you can see that if as a user, you are going to use BLI or with our AAVX Pro, then if you set up a 96 well plate, then in order to run that entire 96 well plate, assuming that each plate is going to take around 2 minutes for a particular concentration range, you would be done in around half an hour, 26 minutes. And that includes, there is no wash tests involved, of course. All you do is you have to pipette your solutions of interest in the plate, and then you just hit the start button and you walk away from the machine. And because you are not having to do so many dilutions and washes and adding substrate and quenching and things like that, of course, there are fewer touch points and you are adding less error, right? That's a huge advantage. And so if you just compare with that ELISA, it kind of frees you up in your lab in order to do other orthogonal techniques, which probably needs your time and attention. And having that in mind, that it's not only advantageous, this our Gator platform and the AAVX probe in terms of time and in terms of the precision and things like that. Another thing that we need to talk about is reusing our AAVX biosensors. We call it regeneration. So as I was mentioning that we are attaching an anti-AAVX ligand on the probe, right? So this interaction is covalent. You cannot you cannot break. And whereas when the ligand is binding to the analyte, in this case the AAV serotype, this interaction you can easily break, because this is the same principle what you do in order to elute your AAV from your column, right? So all you do is you have some acidic solution, you just pass through it, and then the AAV just comes out, right, in your flow through. So this is what exactly we are doing, is we are using a regeneration buffer. Here in this case, it's 10 millimolar glycine, and you are able to get rid of this bond. So now you have the probe with the ligand attached and free of your AAV, which is ready for you to reuse. So if here we are showing that, we have successfully done 10 regeneration using spent media. And you can actually have test it for your own media and buffer and things like that, how many regeneration you can obtain. Easily 10, but I'm sure that you can even go beyond 10 in a lot of cases. So here is a standard curve that how it would look. So this is for AAV8. And if you look at the standard curve, as I was explaining, here is the nanometer shift and here is the time. So the standard curve range for this particular graph is around e to the power 11, all the way goes to 9. Now, when it is 9 here, e to the power 9 particles per milliliter, you can see that between the blank and the last concentration, we do have a little bit of a window where you can lower your concentration range still, and you can detect it. And at the same time, if you see at the higher range, you see that it hasn't been saturated. So you still not only 11, but you actually can go beyond. But for us, we do not have the AAV. We do not have our own AAV to characterize. We buy from the vendor. So the highest concentration that we were able to buy was e to the power 13 particles per milliliter. So that's why our standard curve is in this particular range. But then here is an example where one of our customer, they wanted to, test our stress test, our probes, and they wanted to push the concentration limit, and because they are more interested in the higher concentration range, because we realized after we kind of launched this product that the working concentration range is actually e to the power 9 particles per milliliter is actually low end. You are more interested around e to the power 14, even 15 and 17, some of them. So this lab, they could have like e to the power 14 particles per milliliter concentration. And all they had to do is adjust the shaker speed of our plate. We have shakers in there. So you just slow it down and you just measure it for a shorter amount of time. Thereby you can see the separation between all the concentration. And here you can see clearly that we have pushed it to e to the power 14 particles per milliliter. Now, as I was mentioning, that we also have characterized all the serotypes of AAV that normally you guys are working in the lab from AAV 1 to 8 and 10. And at one particular concentration, we wanted to see what is the binding rate for each serotypes in this particular probe. And do they work in the high, medium, and low concentration range, just to make sure that we are addressing all the AAV serotypes. And here you can see that at e to the power 11 particles per milliliter, we see that different serotypes are binding at a different binding rate. And this is expected, right? As I was mentioning that the anti-AAVX antibody from CapSelect, it does bind to almost all the serotypes, but it binds at a different, slightly different residues. And that slight differences in binding has the difference in their binding rate. And that thereby, when you are using, say, you are using the probe in your lab to do AAV2 versus AAV8. For AAV8, the binding rate is higher. It binds tighter. So you will see the nanometer shift to be a little bit more for that particular concentration. But for that reason, what you have to do is, if you want to quantitate your AAV2 unknown, you need to have your AAV2 as a standard. And then if you want to quantitate AAV5 as your unknown, you need to have AAV5 as your standard. Now, you do not need to run these standard curves repeatedly. You have to run it at the beginning, and then our software will save that standard curve. And then every time you run the unknown, all you do is you recall the standard curve and you calculate these concentration unknown against that particular standard curve. So all you have to do is for individual serotypes, you have to run individual standard curve. And as you can see that our probes work perfectly at a high, medium, and low concentration range, giving a very good precision. Now, we also realized that when doing your AAV purification, where will this probe be used, right? So you would probably want to use for an entire range of your assay. If I imagine the lab and then you are doing your purification, you'd probably be interested when you have your cell lysate before you are loading into the column in the upstream process, right? So this probe works perfectly fine with your media. Here you can see an example where we ran spent media and spiked in with our AAV5, and you can see the percentage recovery, and the precision is also extremely good at the entire concentration range. Then we were thinking of, like, when you have it loading in the column, then you probably would like to see it in your flow through. So there, so you might use some kind of buffer or the lysis buffer. So for lysis buffer also, the recovery is excellent. And we also tried with your pluronic buffer pH 8, because this is also very extensively used, we realized. And this also shows very good recovery. And of course, the sample diluent buffer, where you will finally have your AAV stored, that it works very well. It's the most easiest anyways. So this shows that the probe is robust and it can work through different matrix. And the pH where it works great is pH 6.5 to around 8.5. And whatever buffer we tested, our recovery is excellent so far. But again, you might have some special buffer which you might need to do your slight assay development, but that's like nothing compared to any other technique, like especially ELISAs and things like that. Now, this is an example just to show that how the software will give you the correlation. So here you can see that where we were doing AAV2 standard curve, and these are the standard and this is the unknown. And not only did we run our AAV like probes, but we also ran ELISA side by side, and the agreement between the AAVX probe for the Gator and the current ELISA, we use the Progen kit. They were perfectly in good agreement. And here is another correlation where we saw that for the AAV2, our Gator data as well as the ELISA for the Progen kit compares perfectly well in the high, medium, and low range. Now, for the Progen, they use a different antibody, right? So for the ELISA kits, you do need to use different antibodies for your different serotypes, and this is a different antibody, yet the AAVX probe works in perfect agreement with this particular ELISA kit. So if you are thinking of converting, and of course you would like to cross-check, and we have done some for AAV2 and AAV8, especially for trying to find out the good correlation between ELISA, the one that is mostly used in the market, versus our probes. They have perfect harmony. Now, saying that, giving all this information, so what I showed you before is the competition that we had, right? And then when we launched, where do we fit in? Like when we optimized our probe and our regeneration and everything. So for the concentration range, we are of course not in that range of ELISA, and we realized also working with a lot of our other groups here who are interested in the AAV serotype determination, that they are not interested mostly in this e⁻⁷ particles per milliliter. It's too low for them. They need to do dilution in order to fall in that linear range. So the sweet spot rather for your AAV concentration that you guys are mostly interested in starts from e⁻⁹ to almost maybe e⁻⁻13. And our probes perfectly work in that particular concentration range. So you do not need to have any dilution or whatsoever. And on top of that, these are very, we have 8 channels that simultaneously works. So the throughput is high and you do not need any wash steps or anything, right? So if I, say that in summary, that what our probes are capable of doing, the AAVX probe. So it, of course, can be, you can use it for all your serotypes from 1 to 8 and 10. And then the dynamic range, as I was mentioning, that we are very comfortable with e to the power 9 particles per milliliter to almost e to the power 13 particles per milliliter. But as I showed you, for customers, they are also pushing the limit, and they have already used it for around 14 particles per milliliter. And I'm sure that if you do a little bit of assay development, you can push it even further. Now, these are, as I mentioned, the throughput. So you can run a 96 well plate in approximately about half an hour. And not only that, what you will have is your sample is intact over there, sitting in the same buffer that you want to be. And you can reuse that sample for any of your other bioanalytical techniques that you are interested with those precious samples of yours. Now, as I showed that we do not have any fluidics involved, we do not have any flow cell. So the machine is perfectly tolerant for media, plasma, or any kind of supernatant. And it will never give you any kind of problem. And also the probe is stable over a broad pH range, thereby allowing you guys to have this probe and use the Gator platform all the way from your upstream to the downstream, your processes for total capsid quantitation. And I think the best part about the probe is also that it can be reused for more than 10 times, I think. And another thing is like once you start using, you realize the software in the machine, it's just so easy that you just hit a start button and you go away, and then it just does everything for you. And then you come and there are a few clicks in a button and you are able to analyze your data. So it's simple plug and play, and you do not need a very experienced user. You can have somebody who just comes in the lab and gets training for a few hours, can run this experiment quite precisely. Now, so this is our total capsid quantitation solution that we have launched, the AAVX probe. And this is using our plug and play BLI solution, and it works for both of our Gator platform, Gator Plus and Gator Prime. And currently we launched this, as I was mentioning, last month, and we are just very overwhelmed and grateful also for getting so much of response, because we didn't realize that the AAV market would like the BLI technologies so quickly and so suddenly. And we are also looking for more feedbacks, because we do want to reach out to other applications related to not only AAV, but gene therapy in general. And in-house, we also have some ideas that we are working on, and we hope to keep you posted on our improvements in future. And thanking you all for joining us this morning. And we are ready for your questions. And
thank you very much, Indrani, for a great overview. And on the AAVX probes and how does it compare with ELISA. Before we go into questions, I just want to mention that we have our next webinar coming up on November 23rd, which is Rich in Chips, Tips and Tricks for Getting the Best Out of Your BLI. This webinar is really more about nuts and bolts, how you can use the system to get really good data, not only for AAVX, but for all other antibody applications. With that said, let's go into the questions. We have a range of questions here. The first one is, I think it got answered, but I will ask that question anyway. The question reads, I may have missed this, but is it 21 minutes to run each set of 8 tips? So a full plate would take multiple hours.
No, it's the 21 minutes to run the entire plate. So each row in your 96 well plate will need 2 minutes. And that is also dependent on what concentration range you are interested. If you have very high concentration range, say you are interested in e to the power 14 and above, then you can actually limit that also to a minute or even 30 seconds. So it is very much according to what range you're interested, but we kind of just thought the optimized in the range of e to the power 9 to e to the power 11. That is where you need that 2 minutes for each row. So you think about your all the rows, and it takes 26 minutes. So certainly not the many hours.
Okay, thank you, Indrani. The next question is, do you have to make standard curve differently, one for a higher concentration range and another for low concentration?
No, you make one standard curve, and you do the serial dilution depending on what concentration range you are interested. So you would have like 8 data points depending on how you split them up, right? And now if you have really low concentration range, all we recommend is having that to extend the assay slightly longer so you can see them better. So you do not need to make separate standard for separate concentrations.
Okay. The next question is, why is AAV9 left out of the serotypes that are called out?
You can use AAV9, you develop your assay, because we are using, as I mentioned, capture select antibody, which is the anti-AAVX antibody. And if you go to their catalog, you will see that they specifically mention that it works with 1 and 8, and then 10 and 37 and others. And for 9, they have another antibody, anti-AAVX9. So we intentionally kept that out, but I think you can definitely try for yourself, and it might work for you. And it does, work. We have seen that it works for us. But the binding rate is slightly lower than AAV8 and others, but it perfectly works. And we are also planning on making AAV9 probes, anti-AAV9, which we will be launching next year beginning. So just stay tuned.
The next question is it possible to detect or measure aggregates with this system?
We are, yes, definitely we are interested. We are exploring. But right now, I cannot comment on it. But certainly, we haven't done anything with the AAV. But for the antibody, whenever we have done, what we see that when we detect antibody, we see functional concentration. So what is correctly folded and all that is only going to be picked up by the biosensor, and that's the signal what we see, right? So we assume that we can do it, but we need to explore, because as I mentioned, our product is the first label-free product in the gene therapy market. So we are exploring a lot of assays and biophysical techniques which we can implement in our platform, BLI platform. I can give you an example. Yesterday I saw a data from one of our customers. What they are using the probes is they are loading the AAV serotypes, and then on top of that, they are seeing antibody binding, association, and dissociation. So they are doing kinetics on it. So it's for you to think how you would utilize this probe, because it has so much application. And as what we do is we make the product, but you are the people who would probably take it to the next level by utilizing its potential. That's what I think. So I think you can do aggregate study on it as well.
Excellent. Next question. How easy is the assay when compared to ELISA in terms of experimentation?
I would say that, if you ran an ELISA, you are there almost all day with your timer going back and forth, right? And doing that many wash steps and adding this and that. And this is just simple plug and play. All you do is you come in the morning and have the plate, pipette, put it in there, start, and then you go and have your coffee, come back, your run is done. So it's you just once pipetting, and you do not have to do any other thing. It's a lot more like plug and play, very easy and very easy to adapt. And one thing is also you do not need somebody to come in and train for a longer period of time in order to make sure their pipetting skills are good. They know what they are going to do. It's just you add in your plate and you just start the button and do.
All right. The next one is, do you need to filter or centrifuge lysates before analysis?
No, you don't. Neither you need to filter nor you need to centrifuge. This is the beauty of the BLI platform, because we do not have any fluidics involved. There is no flow cells, no lines that goes in through the buffer. So yes, we realize that your samples are dirty, we call it, and you should be very comfortable in order to put those direct solutions in the 96 well plate and read. Sometimes you might end up having a little bit of a more non-specific binding, depending on what is in your media. In those cases, we recommend that maybe if you want to dilute it slightly in a buffer and things like that, then it might change that non-specific binding. Otherwise, you're perfectly fine.
Okay. We have lots of questions coming in.
Okay.
So we'll go through as many as we can. Otherwise, we will answer by email. The next one is, can you elaborate on the regeneration buffer?
Yeah, of course. So, all our probes, mostly all our probes, right, except for the streptavidin, you can regenerate. And this goes same for the AAVX biosensor. And as I had present like a PowerPoint slide, I can go back to it if you want me to. What it is you have the probe surface, and all we do is we have a glycine solution. In this case, I think it's glycine pH 1.7 and 10 millimolar. So the picker comes and dips in that particular row where it has that solution, and it just is there for 5 seconds, merely 5 seconds, and that is enough to break that bond between the AAV and the anti-AAV. And then you have these probes again ready for you to reuse, which just goes into another column. We call it neutralization buffer. That is basically the buffer that you are using for your assay, so that you don't have any acidic solution left over in your probes. So it's just again another 5 seconds, and then it's ready for you to run for the next sample analysis. It's very simple, and we reuse almost all of our probes, even though we claim 10, and a lot of them are using beyond 10.
Okay. Actually, there was a follow-up question to that. Is this buffer different than what is used for mouse FC?
Oh, somebody asked that. And no, it is the same buffer that you use for mouse FC, just glycine. So the range would be, the pH range is 1.7 to 2. You can use either. I used 1.7, but you can use also pH 2. So that's the mouse FC buffer.
Okay. How do you make sure the probes are clean between the rows?
Meaning, how am I making sure that if it's clean between runs, right? So what we have done is, I also have, we bought anti-AAV antibodies. So now if there is any antibody in your probes still attached after the regeneration, because we do this like moving into acidic solution, bringing back to the neutralization solution 3 times, just to make sure that it's clean. Even after that, what we have done is we had, say, AAV2, right? So we came in with just an anti-AAV2 antibody, just to make sure if anything is binding to the probes. If there is any AAV2 still attached, then this antibody would show binding signal, right? But we did not see that. So we can claim that they regenerate perfectly fine between each runs.
Okay. There is a question about, have you done, or could you compare performance of Gator AAVX probes versus Octet?
In my knowledge, I do not think they have any AAVX probe. We are the first, the label-free company to launch a AAV product. What they have, I believe, is an application note. And if you are interested, we can send you the application note. And that only talks about AAV2. That's all.
Okay. There is another question, which I'm just trying to see. Yeah, there's a question about the comparison, and this is more around the instrument.
Okay.
How does the Gator compare with Octet?
I don't know if I can give you a good answer on that. You have to use Gator and Octet both in order to compare and contrast. But of course, you know, they are they have the same biophysical technique that is involved in order to see the real-time binding. That's the only similarity I can think of.
All right. The next question: do the probes bind only intact AAV particles? No fragments?
No, no fragments, because that is all dependent on the antibody which is on the probe, right? That this antibody is very selective to the intact AAV particle. So that's why it just binds to the intact AAV, but it binds to empty and full. So this is a total capsid quantitation, not empty and full ratio.
Okay. The next one is there any temperature effect on method performance?
Yes, now that you mention, of course, in Gator, you know, you can have it warm up to 40 degrees, and then you can also have it at room temperature, right? So binding rate is always temperature dependent. You have it at higher temperature, the binding rate is higher. We tend to do everything at room temperature, but if you have any specific, you know, requirements, you certainly can push that limit to 40 degrees.
Okay. There is a question about pricing of the Gator total solution, and I think we will take take that offline.
Yeah.
Let's see. There are some more questions. The other question is, can I use any commercial available reagent to develop my own AAV assay?
Of course, you can. So we have like streptavidin biosensor. You can have any other, you know, whatever you want, you biotinylate, and you can have that on our assay biosensors, and then have that as your own homemade biosensor, right? And at the same time, we have mouse FC probes, we have HFC probes. So when you think about the Progen ELISA kit, the antibody is a mouse antibody, right, that they have attached to that kit. So if you want to be that specific that, you know, you want to use one particular antibody, you certainly can use our mouse MFC or HFC probes in order to have bind to that. So you can make any kind of probes that you would want to do any kind of experiments. It's very open-ended. It's, you know, what you want, it has the format to adapt to.
Okay, and I think we will take one last question. And what is the recommended buffer for your AAVX assay?
As I mentioned, you know, the easiest, you can even do with PBS, but then it works perfectly well with cell lysates. It works with lysis buffer. It works with any twin in there or any kind of BSA. But in BLI in general, the buffer that we recommend is it needs to have like some BSA, some twin, and some PBS. So in order to avoid some non-specific bindings and things like that. So that's the ideal buffer. But you can choose to use any buffer and optimize your assay, and that also doesn't require that much time.
Another question also related to, I think, the pricing. Is it possible to provide costing? Yes, we will send you by email on all the details about the pricing and configurations, etc. I think with that, there are a couple more questions, but I think we're running out of time here. So we will respond by email. So again, thank you very much for attending this webinar. We hope this was educational and also good use of your time. And again, at the end, if you're interested in knowing more details about the actual operation of, in general, of BLI, how to get the best data for kinetics and quantitation, then please join us on our next webinar, which is titled Rich in Chips, Tips and Tricks. You can just scan the QR code and registered. Thank you very much and have a good Friday. And with that, we close the meeting.